All right, moving right along, we are covering solving right triangles in 2.3. This is going to be split into two videos. Part one, we're going to cover significant digits, and then part two, we're going to look at solving triangles. Okay, all right, so take notes. All right, 2.3, solving right triangles. Okay, this is acting kind of strange. Okay, solving right triangles. So like I said, we are going to be covering significant digits. Maybe you learned about this in your science class. Um, ugh, yeah. Um, these are also known as significant figures. So significant digits, significant figures. I like using the word figures because uh, okay, now it's not writing. Hold on a second. Things are getting weird. I think my device is getting tired, just like I am. I might have to do this later. All right. Oh, there it is. You're going to start to see a bunch of scribble probably. Okay. There it is. See, now it's me trying to see if it works. I might have to do a take two. No. Why? This keeps it interesting, right? Okay. Significant digits, or maybe you've seen it called significant figures. I'm going to use figures because that way we can just shorten it to sig fig. Okay. If we can get it to write. Okay. So, AKA sig fig. Okay. Uh, and we are also going to look at solving triangles. Solving triangles. Whether they are missing sides or angles. Now that we know how to use the inverse function, the inverse trig function to find an angle, now we can find missing angles of a triangle. Okay. All right. So significant digits. Significant digits. Okay. It might seem a little complicated at first, and it kind of is, but then once you make sense of it, then you're like, oh, okay. Not really make sense of it, but make sense of the rules. Okay. So for finding significant digits, like how many significant digits, you're going to first, you're going to count from left to right, count left to right. Okay. And when you count from left to right, you're counting how many digits or significant digits there are. Okay. So you'll be counting left to right. You have to start with the first non-zero, with first non-zero digit. This rule comes into play when you have like decimal numbers. So like if you have 0.000007, right? Okay, so all those zeros are insignificant because you have to, according to the rule, you have to start with the first non-zero digit. Okay, so and then for the decimal, if you do have a decimal, here, let me give you an example of this top one because some of you guys are visual learners. So here, So here's an example. So if you have all these zeros, 0.042, okay? So it says here, start with the first non-zero digit. Okay, that's a 0, that's a 0. So then this is where I start to count. Okay, and it says count left to right, but you have to start with the first non-zero number. So this one doesn't count, this doesn't count. This is where we start counting, first non-zero numbers. So it's 1, 2. So this one has 2 significant figures. Okay, if you have something like this, 0.005. Okay, so again, you count left to right, but you have to start with the first non-zero number. So doesn't count, doesn't count, doesn't count. Here it is, first non-zero number, 1. And that's about it. So this one only has 1 significant digit. Okay. Now for the decimal cases, okay, so we have 2 cases. 1, if the decimal is present. Okay, so if decimal is present, okay, trailing zeros count. The trailing zeros are the ones after, you know, like in 1 million. Those zeros after the 1, those are trailing zeros. Okay, so trailing zeros do count. Okay, but again, only if the decimal is present. Okay, so if I said 1 million with no decimal, all of those zeros do not count. But if I say 1 million decimal point, now all of those zeros count. Okay, let me give you some examples here. So if you have 6.000, this one has 4 significant digits. I'll say sig figs. Okay, significant figures. Okay, if I have 9200, if I have that point there, then those zeros count. Okay, so again, it says if the decimal is present, there is a decimal present, so these trailing zeros count. There is a decimal present, so these trailing zeros count. So this one also has 4 significant figures. Okay, now, if the decimal is not present, then they don't. Okay. Don't count. Don't count trailing zeros. I'm running out of room. Okay, don't count the trailing zeros. All right, so for example, if I have 700 versus 700 with a decimal, right? If the decimal is not present, don't count those trailing zeros. So this one has 1 significant figure. And this one, because the decimal is present, it has 3 sig figs. Okay. All right. So, so that's basically what you have to remember. You you have to start your counting with the first non-zero number. Okay. Doesn't count. You have to start there. And then the trailing zeros only count if the decimal is present. Okay. If it's not present, they don't count. So you only have 1 significant figure. Okay. All right. So let's go ahead. Try these 4 problems. How many sig figs, significant figures or significant digits? Okay. So try this one. That one. this one, this one, and this one. Okay, so you don't have to, well, I guess you're taking notes, so you can write them down. Okay, so let's do this together. All right, so this one here, no decimal present. So how many significant digits are there? 1, 2. Trailing zeros don't count. They only count if you have a decimal. Okay, so this one has 2. Here, how many significant digits do we have? Decimal present, trailing zero will count. So 1, 2, 3. Okay, over here, no decimal, so trailing zero doesn't count. So 1, 2. And then over here, we have to start counting at the first non-zero number. So doesn't count, doesn't count, doesn't count. 1, 2. So this one has 2. Okay, so hopefully that makes more sense. Try these. Okay, number 5, 374. Number 6, 0.0374. Number 7, 3.7400. And number 8, 374,000. Okay, so give these a try and then come back. Okay. All right, so this one here has 3. Okay, so it's always when there's zeros involved where it gets a little confusing. Okay, so over here, again, we have to start with the first non-zero number. So this doesn't count, this doesn't count. So 1, 2, 3. All right, this one over here, these are trailing zeros. Decimal is present, trailing zeros count. So 1, 2, 3, 4, 5. Okay. Over here, these are trailing zeros, no decimal present. So trailing zeros do not count. So we only have 1, 2, 3. Okay. So hopefully that makes some sense. Okay. Now, okay, so when we start solving for the missing parts of a triangle, here are some sides and angles relationships, so that you know, okay, well, what do I round to? Do I do 3 significant digits, or do I do 4 or 2? Okay, so copy this table for sure. Sides, angles, relationship table. All right. And the table will probably make more sense once we start to use it. Okay. So accuracy of sides. Okay. So accuracy of sides. And over here we'll have accuracy of angles. Okay. All right. So your sides, if your sides are 2 significant figures, so if your sides are 2 significant figures, then your angles are going to be to the nearest degree. So you might have to have this handy when you're doing your assignment until you have it down, memorized. Okay. If your sides are 3 significant figures, then your angles are going to be the nearest 1/10 of a degree. nearest tenth of degree. Okay. Uh, okay. If your side is four significant figures, then you will round your angles to the nearest hundredth of a degree. That's two decimal places. Okay. So keep that in mind while we are solving triangles. Okay. So I'm going to go ahead and stop right there. And the next part two, we will actually try solving some triangles. Okay. All right. I will see you in the next one.